Hello, everyone. So in this video, I'm going to talk about how we actually can graph a rational function. So it's a bit involved, so it will take a bit longer. But at the same time, we do review a lot of stuff with the graphing rational function. So let's bear with me. So the first one, like let me write the equation first. Like this is the equation I like to graph. So I'm going to use y is x minus 1 over x squared minus 4. Okay, so this is the equation. That's a rational equation we like to graph. So first things first, we have a lot of things to really find out to determine the graph of the function when we do this manually. So the first thing is we want to make sure that the function is a factor, like simplify as much as possible for numerator and denominator. So which is why this denominator is actually can be written like x squared minus 2 squared when you have x squared minus 2 squared, which is going to be difference as square. So we can actually factor that. So in this way, so x minus 1 over the x minus 2, okay, times x plus 2. So again, this is called difference of squares. So this denominator is going to be equal to this, and then you can just go ahead and multiply the FOIL this to get this one. So if you are not convinced, so this is something we have, and I'm going to just draw like our axis, even though I don't have much information yet. So let's try something like here. Okay, so now we do have the simplest version. The second thing we need to look at it is the domain of this function. So the domain, right? So what our x value is possible. So we can plug usually anything in like polynomials, but with the rational function, we really cannot have denominator 0. So which means these two like factor can't be 0. So which means whatever makes denominator 0 is not good. So this factor will be 0 if I choose x is 2. This will be 0 if I choose x is negative 2. So that means those two x values are not part of the domain, but anything else should be good. So which is what I'm going to write in terminal notation. Everything starting from the negative infinity all the way to the negative 2. Okay, so anything between these two are good. Union, so negative 2 all the way to the positive 2. So this is also okay, anything between negative 2 and positive 2. And then we also have anything larger than 2. So 2 to positive infinity. And then this is called like the interval notation. So we have some other ways of writing that. So, but this is one of the ways I write the domain. Okay, so we got the domain and we write the function in the lowest term, which means we simplify numerator and denominator as much as possible. So which means there is no like common factor for the numerator and denominator to cancel. So which is, we are good now with the simplifying. And the next thing we are going to do, we are going to find the intercepts. Okay, so we usually try to find the intercept by plugging zeros for x and y. So if I choose x is 0, that will give me my y-intercept. If I choose 0 for this x, so you will just get y value is going to be 0 minus 1 over 0 squared minus 4, which is going to be negative 1 for the numerator, and then this is going to be negative 4. So this is just going to be 1/4. So meaning that the y-intercept is 0, 0, 1/4. So this is my y-intercept. So it should be somewhere right here. So let's say this is 1/4. Okay. So then the same reasoning, if I choose like y equals 0. So usually I just write right here y, but this could be written as any way. So I can write f of like x or r of x, or maybe r of x might be the 1 because that's named for a rational function, but it doesn't make any difference. So that's equal to our y value. So now if you want to find the x-intercept, then you make the y is 0. So if y is 0, right, then you're gonna get x minus 1 over x minus 2 times x plus 2. So we don't need to do this much work maybe for the x-intercept, because whenever you're finding y to be 0, which means this result should be 0, only way that will happen if my numerator is 0, which means if you are looking for the x-intercept, just try to look at the numerator and make it equal to 0. But if you don't remember, you can just always write the y equals 0 and plug it and get what you want. So again, x minus 1 divided by expression should be 0. So only way that will happen if that x minus 1 is equal to 0. So meaning that x is equal to 1. So x is 1, but that's not our x-intercept. Like 1 comma 0 is our x-intercept. So since I choose this distance like 1/4, so maybe I will go with this as 1. But my figure is probably not really a scale, but it's fine. So now we got the x-intercept and y-intercept. Those are my two important points. And also we have to know like the multiplicities as well. So multiplicity is a solution or a zeros of any factor of numerator and denominator will make that equal to 0. So like the x minus 2 is equal to 0 when x is 2, which means 2 is as like a zeros of the denominator, but x minus 2 as a factor is happening 1, which means the power of this is 1. And the same thing with 1, x minus 1 has power of 1 as well, which means each factor has power 1, which means odd multiplicity. So whenever you have odd multiplicity, which will tell us our like function, like it'll cross the x-axis at these zeros. Okay, so that is something we have to remember. So let's find the asymptote as well. So to find the asymptote, we look at the denominator to find the vertical asymptote. So let's go ahead and do that. So what makes the denominator 0 is going to be our like vertical asymptote. So if I want to make this x minus 2 is 0, x is equal to 2. So this is going to be one of the vertical asymptote. And then this will be 0 if I choose x is -2. So that means this line and this line are our two vertical asymptote. Okay, so these are my vertical asymptotes. So let's go ahead and draw these. So it will be, this is 1, so maybe 2 will be somewhere here. So when we draw the asymptotes, we just try using a dashed line. So this is x equals 2, and let's say this is -2. Okay, so to find the horizontal asymptote, we have a bit complicated. So there are a couple ways, but first things first, we look at the degrees of the numerator. So degrees of the numerator is 1 because x has a power of 1. So degree of the numerator is 1. Degree of numerator is less than degree of, I will use this notation, the denominator. The denominator has a degree of 2. So I will say degree of the denominator. So since degree of the numerator is lesser than degree of denominator, you are going to always get way bigger number in the denominator than numerator when you choose x larger values, right? So if you choose x is 1000, then this will be 1000 minus 1, which is like really close to 1000, and this is going to be 1000 squared minus 4, which is really close to 1000 squared, which is why we really like ignore the 1 and -4, -1 and -4. So we just compare those highest degree terms, which we call power function. So which means if your denominator is way bigger than numerator, so you are dividing smaller number way big number, so that means that will be approaching to 0. So which is why we always get our horizontal asymptote y equals 0 when the numerator has less degree than denominator. Okay, so we have now this one, but I'm gonna use different color for this. So this is my horizontal asymptote. Okay, so y equals 0. So that should be this line. So it looks like a bit complicated because we do need a lot of stuff to graph the function. So now we have this much already. And what we need is some other points as well, right? So we just have x-intercept, y-intercept, some lines. So one of the things that we usually try to find is some point that's really close to our vertical asymptote. So which is why we just make a table of values. So since I don't really have my space right here, so I'm gonna clean this part so I can make my tables. Okay, so these are my info like the vertical like lines. So let's make a table. So if I have this is X and this is Y, okay. So then I'll see. So let's choose something to the right. This was 2, X equals 2. If I choose 2.1, I can, or I can choose something really like, I don't know, like close to, let's make it the integer first. And if we need something decimal, like really close to 2.2, which is like 2.1, 2.2, we can. If I plug 3, so that will be 3 minus 1, which is just 2. So I'm going to write here, so 2 over. So 3 minus 1 is, 3 minus 2 is 1. And then 3 plus 2 is 5. So 2 over 5, which is going to be 4 over 10. So it has to be 0.4. So that will be 0.4. So let's ignore this stuff. Okay, so we have 0.4, which is gonna be 3 comma 0.4. So if this is like 3, so 0.4 will be like smaller than this. This is 1.25, 0.25. This is 0.4, so it should be a bit larger actually. So something like this. And then I can just choose something else. Like if I wanna make it like 2.1, right? So I can plug it right here. So if I plug it 2.1, 2.1 minus 1 is just 0.1 over. So 2.1 minus, actually this is 1.1. 2.1 minus 1 is 1.1 over. So 2.1 minus 2 is 0.1. And then times x plus 2, which is 2.1 plus that, which is 4.1. So like, this is going to be 1.1, but this is 0.1 times 4.1. If you plug this into calculator, so it will give you the value. But if you can approximate this, we actually can do as well. So what I will try is basically kind of finding the values immediately, because I can multiply the denominator by 100, by numerators by 100 as well. So that will be 1 and 41. And this will be 110. 101 over 40 is like 3 point something, which means my y value is getting actually bigger and bigger. So when you get close to this one, so I will say if I choose 2.1, so my y value will be somewhere right here. So let's keep this in mind. And based on this, we actually have a graph, because we have to go through this point, but we are not gonna touch this line. We are gonna get close to this line as well. So which is why you can try some other values, you can see a bit better. But for now, by using this asymptote, we can just connect these 2 points to make a curve. So it will be something like this. It will go this way forever, and then it will go that way forever. So this is one branch of the graph. And we can just use the same thing with this side, and then we can use the same thing with this guy. But let me try this one first. This was -2. If I choose -3, because so that was, I guess we got this approximately 3. So something like this. You can check that if this wasn't 3, but I think it was something like that. So if I choose -3, so -3 minus 1, -4. So I will fill in this part. So that will be -4 over. So -3 minus 2, -5. And then -3 plus 2, -1. So you multiply this. This is going to be positive number. So that should be like -4 over 5, which is going to be -8 over 10, -0.8. So -0.8. So if I try this one. So again, I just don't use calculator, so just check that. So I have that's correct. So -3 and -0.8. So it looks like I'm gonna get something right here. So because this was -2, if I take this as -3, so I don't want to just go too much, like too down. So that's something like that. And we have 1 point. And also, you know, we do like see, like, I'll actually get this point soon. So we can try one more point. I can try, I don't know, like negative, like something else. Like, what is that something else? I can try maybe negative, like negative 4 or negative 2.1. So if I really want to get this close, so let's go with negative 2.1. So if I plug negative 2.1, so that should be negative 2.1 minus 1, which is negative 3.1, over negative 2.1 minus 2, negative 4.1. And then this is going to be negative 2.1 plus 2, negative 0.1. And if you don't get this in your head, so you can always probably use calculator. So for the denominator, we have 2 negatives, that's positive. Denominator was negative, so that will be 3.1. I'll just plug into calculator for this part. Divide by 4.1. I'll take the signs after. Okay, and then divide this by 0.1. Okay, so let me check that. So divide the 3.1 by 4.1. Okay, and then divide that by 0.1. So it looks like 7 point something, but since this is like negative, this is positive, so that should be negative 7 point something. So that will be approximately this number. So which is good, because when you choose something really close to it, so you are getting like close to this line. So based on this graph, maybe I should clean this so we can kind of see it. So we know how to get the horizontal asymptote and stuff, so I just don't need this anymore. So let's clean this mess. So I removed one of my other points as well. So what we did have was negative 3 comma something, right? So we need to get through this point, but we are getting close to this line. We are getting close to this line as well. So if you try kind of connecting those in a way that you are getting close to those 2 lines, so it will be something like this. So my graph is not really accurate, so you can just kind of plug this into calculator and see how that looks like. But the curve of this, I think, should be same as this one. So maybe this was not really a scale. So, but the point is the same. Okay, so we are good with that. So now we have this branch, and we need something between. So, and also, you know, when you have negative 2, which was like this guy, this was the reason we have this vertical asymptote. So the power of this is 1, which means this is like this guy has a multiplicity of 1, which is odd number. So meaning that when you look at the asymptote, the graph will approach that asymptote in different directions. So if when you look at the left side goes this way downward, so when you look at the other side, so you should go upward. So that's kind of the behavior, because it has to be opposite. And we have to go through this point. And the similar reasoning, x equals 2 has a power of 1, which means that's also odd multiplicity. Since this goes upward, so we should have downward. So it looks like we're going to start from higher and then get to this point, pass through it, and then move on. So that is the graph. And if you are not convinced, you can always plug some other points. Like I just didn't do that, but you can try negative 1.9. So to get something that is positive like that, then you can try negative, like positive 1.9. So to get the y value from here. So by doing those, you actually confirm what I just mentioned. So if I try my like graph to connect, so it will be something like this. So you will have to pass through this y-intercept and then pass through x-intercept. This was y-intercept, this is now x-intercept. So it should be something like this. Okay, so again, it wasn't easier, but I think a bit longer than maybe it should be. But I hope that was clear. So, and then there are some like question that I did not answer, where maybe sometimes like, you know, this is the horizontal asymptote, right? So now my graph actually goes through this point, which means my graph actually passes through a horizontal asymptote, which is possible, but you never cross a vertical asymptote. So if there is a case that you have a curve that goes through the vertical line, so that shouldn't be the case. So you never touch the vertical lines, because that is the reason we have denominator 0, so which is we cannot plug those x values. Anyway, so I hope that was clear. So this is one of the rational graphs. So I hope that does help. Okay, I'll see you in the next video.